All right, so let's go look at problem number 8. This is a proof. We have 2 lines here on the reason side that say given. And I have 2 pieces of given information, so I'm going to write 1 on each line. I've got this piece here, AC bisects angle BCD. And then I've got this piece of given information that I'm going to put right below it. BC is congruent to DC. Most of the time, I don't take up 2 lines to write my given information. The only reason I'm doing it this time is because they had my reasons filled in for me on those 2 lines. So that's how I knew I had to take up 2 lines for that. But most of the time, I don't do that. Is there anything that I'm allowed to mark on the picture even though I wasn't given that information? AC is congruent to itself. So AC congruent to AC, thank you. And why am I allowed to say that? Reflexive property. I just realized that I did not mark this piece of given information on my picture yet, and it wasn't marked for me already. BC congruent to DC. I want to make sure that that's marked on there. How many pieces of information do I need to be congruent? How many corresponding congruent parts do I need? I need 3. How many do I have right now? I have 2. I have these 2. I have a side here and a side here. But I haven't used this piece of given information yet. It says that AC, well, here's AC, bisects angle BCD. Well, angle BCD, I'm going to look at that middle letter, C, that's my vertex. So I'm looking over here. So from B up to C, and then C down to D. That's what's being bisected. What does bisect mean? To cut it in half. And when I cut something in half, I end up with 2 parts that are exactly the same. What kind of an object is being cut in half? What is being bisected? What did it say is being bisected? Angle BCD. So I'm cutting an angle in half. When I cut a candy bar in half, I end up with 2 smaller candy bars. When I cut a segment in half, I end up with 2 smaller segments. If I cut an angle in half, I'm going to end up with 2 smaller angles. So what are the 2 smaller angles that are going to be the same size as each other? What'd you say? C1 and C2. We can call them angle 1 and angle 2 if we want to because it's labeled on our picture. Or we can give it a 3-letter name. So we could call this angle 1 congruent to angle 2. Or I could say angle BCA is congruent to angle DCA. Either one of these. You don't need both of them though. How did we know we were going to end up with 2 little baby angles that were the same size? What was said to us so that we knew we were going to end up with 2 tiny angles that are equal to each other? Bisects. And what kind of an object did we say was being bisected again? What was being cut in half? An angle. So this is the definition of an angle bisector. Do we have enough information marked up on the picture to say that these two triangles are congruent to each other? Yes. So I'm going to recopy my triangle congruence statement down here that they wanted me to prove. Triangle ABC is congruent to triangle ADC. Which triangle congruence criteria are we using to say that those two triangles are congruent to each other? Side, angle, side. When I do side, angle, side, what I see is kind of like a puppet mouth. So I'm going to have two sides that are marked. And then where those two sides come together, that is the angle that's marked. So I see kind of like this puppet thing. That's how I look for side, angle, side. All right, what else would you guys like to see off the review? Number 11. All right. So on number 11, we've got X's and Y's in the problem. First thing I'm going to go looking for, though, anytime we've got angle stuff going on, I'm looking at my angles. Because I know in any triangle, those three angles are supposed to add up to what? Supposed to add up to 180. This angle, though, is not inside my triangle. What do we call angles that are not inside the triangle? Exterior. This is an exterior angle. And we had an exterior angle theorem that we learned early on in this module. This tells me that that exterior angle, so in this case 108 degrees, is equal to the sum of the two remote interior angles, angles that I would have to walk across the triangle to get to. So these are my remote interior angles, and I'm going to add them together and it'll give me that outside angle. So y degrees plus 54 degrees. What would I need to do to this to figure out how big y is? Subtract 54 degrees from both sides. What is 108 minus 54? 54. So y is 54. I'm going to include this on my picture now. I know that this is 54 degrees, which means this is what kind of triangle? What kind of triangle does this have to be? Isosceles triangle. We have a 54 degree angle here, and I have a 54 degree angle here. When I have an isosceles triangle, two of my angles are the same size, which means what else happens? Isosceles triangles don't just have two angles that are the same. Two sides are the same size. Well, which two sides are the ones that are the same size? I've got stuff written on all three sides. Which are the ones that are congruent? The 2x and the 7x. So the 2x one is across from my left-hand angle. So that's one of my two congruent sides. And the 7x down at the bottom is across from my 54 degrees up at the top. They are the same size as each other, which means I can take those expressions and set them equal, because those sides are the same size as each other. Whenever I'm trying to solve an equation and I have x's on both sides of the equal sign, First thing I'm going to do is get my x's to the same side. So I'm going to subtract 2x from both sides. I could also subtract 7x from both sides, but I like to keep things positive, so I usually minus the smaller one. 7x minus 2x gives me 5x. So I have 5x minus 14 equals 16. What do I do next? Add 14 to both sides. So I get that 5x is equal to what? What is 16 plus 14? 30. 5x equals 30. And then when I divide both sides by 5, I figure out that x is 6. So y is 54 and x is 6. What other problems on the review would you guys like me to do? Number 10? Absolutely. In triangle BRK, the measure of angle K is 7 less than 3 times the measure of angle B. The measure of angle R is 30 degrees. How many triangles are we talking about here? They talked about 2 triangles? They just talked about 1 triangle. And they gave us information about the sides or the angles on that 1 triangle. The angles. Well, what do we know about the angles inside of 1 triangle? They add up to 180. So I'm going to use my triangle sum theorem. If I add all 3 of those angles, so the measure of angle B plus the measure of angle R plus the measure of angle K, if I add all 3 of those angles together, it's going to add up to 180. Well, I know that angle R is 30 degrees. So I'm going to come over here and I'm going to substitute 30 in the place of R. It says that K is 7 less than 3 times the measure of angle B. Which angle do I have absolutely no information about at all? Oh, I know K is 7 less than 3 times. I don't know anything at all about B. So if I don't know anything about it, what should I call it? I'm going to call it X. So in the place of B, I'm going to put X. It says that K is 7 less. 7 less means what operation? Subtraction. We're going to subtract 7 from what? I'm subtracting 7, so I need a minus 7 after something. Subtract 7 from what? What does it say next? 3 times the measure of angle B, and we're letting X mean the measure of angle B. So I'm going to subtract 7 from 3X. So that's what I'm going to put in the place of the K over here. 3X minus 7. All right, so I have expressions representing all 3 of my angles. I'm going to combine my like terms together. What like terms do I have? I have X and 3X. What do I get when I combine the X and the 3X together? I get 4X. Any other like terms that I should be combining? 30 and minus 7. What is 30 minus 7? 23. So 4X plus 23 equals 180. To solve this for X, I need to subtract 23 from both sides. Thank you, Kyron. So 4x equals, thank you. What is 180 minus 23? 157. And then I divide both sides by 4. And I get that x is what? What is 157 divided by 4? 39.25. I'm supposed to find the measurement of angle B. What did we have that was representing the measurement of angle B? X. So this is just going to be 39.25 degrees. How do I find angle K? Substitute in, this is 3x minus 7, so 3 times 39.25 minus 7. What is 3 times 39.25? You said 117.75. Minus 7 would be what? 110.75. That's the measure of angle K. Classification of triangle BRK. Well, angle R. What kind of angle is angle R? That is an acute angle. What about angle B? That is also acute. Angle K, that is obtuse. Are any of my angles the same size as each other? No. So what kind of triangle is this? We have one obtuse angle and two acute angles. So it has to be obtuse. If a triangle has even one obtuse angle, the whole triangle is obtuse. That's classifying it by my angles. Remember, 3 acute angles means it's an acute triangle. 1 obtuse angle, and it's an obtuse angle. 1 right angle, it's a right triangle. Then I also have to classify it by the sides. My sides are either equilateral, where they're all the same, isosceles, where 2 of them are the same, or scalene, where none of them are the same. Scalene. How do we know? None of the angles matched. So none of my sides are going to be the same size as each other. This is an obtuse scalene triangle. Yes, passes right there. All right, we've got 11 minutes left. What else would you guys like to see? $20? Absolutely. Very last problem, number 20. Once again, I've got 2 boxes for my given information, so I know I'm going to need to take what they gave me and split it up into 2 pieces. The other thing that I know is that on this given box right here, it has 2 arrows coming off of it, which means I'm going to be able to get 2 pieces of information from this one. This one over here, I'm only going to be able to get 1 piece of information from because it only has 1 arrow coming off of it. So I'm going to take this right here about the congruence. That's going to come over here. Somebody's got earbuds in and it needs to be taken out and turned off. I'm not sure who it is, but music needs to be turned off. IM is congruent to KN. So this is congruent to this. My other piece of given information, talking about parallel, IM is parallel to Kn. I'm going to put in this box because I'm going to be able to get more than one piece of information from this. When they tell me about things that are congruent, that's all I'm going to be able to get from it. The symbol that means parallel is a little arrowhead. So I'm going to draw those little arrowheads on here. When they tell me about things that are parallel, we make what shape? A Z. Anytime they talk about parallel, we're going to make a Z. So if I go over IM and KN, is there any way that I can connect those two by making a Z-type shape? I heard if I went along IN, I could have also gone along MK, and we'll do that here in just a second. If I follow along IN, and so I make this Z shape, what angles are the ones that are congruent? If I go along this, and then this, and then this, which are the ones that are congruent? I and N. Orange to orange, orange to orange. Angle I is congruent to angle N. It doesn't matter which one of these boxes I put this in. I could put it in that one, or I could put it in the box that's right next to it. The Z shape helps us find what? Alternate interior angles. So we are using our alternate interior angles theorem. So we could have gone and connected IM to KN using MK. If I connected them that way, making that backwards Z shape, which angles are congruent? M and K. So angle M is congruent to angle K for the same reason. Those are alternate interior angles. So I'm using the alternate interior angles theorem. There's something that I didn't mark on this picture that I'm allowed to mark for free. What did I not mark? I didn't mark my vertical angles. They didn't give me a box for it, and I don't need it to show these two triangles are congruent. But if I was doing this as a 2-column proof instead of a flow chart where they already had pieces laid out for me, I absolutely would have come in and marked my vertical angles here.
But like you said, vertical angle. Why can't you just like say M and L is like M is congruent to KL if we know that like they're sharing? Like if we know.
Why can't I say segment ML is congruent to segment KL?
Yeah.
Because I don't know that L is right in the middle of them.
So
For all I know, somebody drew this really poorly, and it's actually supposed to be like this.
So it has to say that.
It has to say either bisect or midpoint in order for me to mark the segments congruent. That is a great question. With the way we've got stuff marked up right here, I have enough information to say that these two triangles are congruent to each other. Using which triangle congruence criteria? What's marked up here? Angle, side, angle. Remember, to use angle, side, angle, I go find the side that's marked. That's this guy right here. And either end of it should have a marked angle on it. That's why this is angle, side, angle. Let's name these triangles. I'm going to name the first one. Let's call the first one IML. If I call the first triangle IML, how would the second triangle have to be named to make sure that I have all the right parts matched up? NKL. That's not where I'm ending my proof. There's one more box. What was I supposed to be proving on this? IL is congruent to LN. So that needs to come down here. IL is congruent to LN. When I look at my triangle congruence statement, I and L are the first and last letter here. And N and L are the first and last letter here. So they're in the same position as each other in those triangle congruence statements. When I look at the picture, IL is right here, and NL is over here. What do we call parts that are matched up with each other in that congruence statement? Corresponding parts. These are corresponding parts. And what did we just say about these two triangles? They're congruent to each other, so they are corresponding parts of congruent triangles, and so they have to be congruent to each other. CP, CT, C. Corresponding parts. If they have the same position in that triangle congruence statement, then they are corresponding parts. All right, 3 minutes left. Let me see. Yes, I can absolutely do 19. If K is the midpoint of JL, so let's draw JL here. Here's J. Here's L. There's K. K is my midpoint. What do midpoints do to segments? Cut them in half. So what does that mean about either side of that midpoint? They are congruent. What did you just use to be able to say that? Definition of midpoint. Or I would also accept midpoint theorem. Is not the same thing, but it's close enough for what we're doing that I'll count them as being the same thing. Answer key for the test review is already posted in Canvas. To get to it, you have to click on modules and you have to find today's module. Once you find today's module, you have to click on the page, and then it's all the way down at the bottom of that page. So modules for today, click on your page, scroll all the way down. I'm also posting videos for all 5 of my sections of geometry. So if you had a question about one of the ones that we didn't go over in class today, check out the videos from my other classes. That will hopefully also help you as you are studying for your test tomorrow. Make sure you turn in the warm-ups on your way out the door. I have after-school tutoring today for a half an hour after school if you want to come and work with me. Send me messages in Canvas if you have any questions.